Hey guys, so today we're going to be going over Leetcode problem 938, a range sum of a binary search tree, which is a tree problem. In this problem we are given the root node of a binary search tree as well as two integers L and R, and what we need to do is traverse the tree and return the sum of the values for each node whose value falls between
in a
L
binary
and R
search tree.
inclusive. We know that any node in a branch to the left of a given node will have a value less than that node, and any node in a branch to the right of a given node will have a value greater than that node's value. Let's take a look at this example binary search tree. Here we see we have 10 as the root node. Everything to the left of the root node is less than 10. If we look at the 5 node, we see that 3 is to the left and 7 is to the right. These placements make sense as 3 is less than both 5 and 10, but 7 is between 5 and 10. Similar logic can be applied to the branch to the right of the root node. We are going to take a recursive approach to solving this problem and implement a depth-first search solution. Because we are only interested in summing up all values that fall between L and R, we can trim branches off of the search space based on whether the value of the current node is less than L, between L and R, or greater than R. Let's take a look at the implementation. First, we'll create a helper function called DFS_range_sum, which will make the recursion cases more clear. Then we will fill in this function. First, we define our base case, something that every recursive function needs, and this is when the node we are looking at is null. If this is true, we will return 0. The next case we care about is if the node's value is between L and R. If this is the case, we want to add the current node's value to the DFS range sum of the left node plus the DFS range sum of the right node. Finally, we want to cover the case where the node's value is not between L and R. If this is true, we know we can prune one of the branches and will only need to focus on the branch that could possibly contain values between L and R. If the current node's value is less than L, then we want to return the DFS range sum of the right child node. Otherwise, the current node's value is greater than R, so we want to return the DFS range sum of the left child node, since that's the only branch that can have nodes that meet our criteria. We click submit and wait and see that our submission was successful, which leads us into our space and runtime complexity discussion. The time complexity is O of n because in the worst case scenario we will check every node once. The space complexity will be O of d, where d is the number of levels deep that the binary search tree is. And that will do it for today's video, so be sure to subscribe and give me recommendations on what problems you guys would like to see me do next.